Compound inequalities are two inequalities that are joined by a word, either and, or could be the word or. In order to graph them, in order to find the solution for a compound inequality, you're going to first graph each inequality, and then you're going to look, in the case of an and, you're going to look for the numbers that are in both of the solution sets, and you're going to put an answer down here. As I graph these, what I'm going to do is we have two inequalities. I'm going to put my smaller number here and my larger number there, and I'm just going to put it in all three spots here. So 0 and 3 coming all the way down. Then I'm going to graph the first inequality, which is x is less than 3. Then I'm going to graph the second inequality, which is x is greater than 0. And this represents all the numbers that make this true. So 2, 1, all these numbers down here are going to make this inequality true. And all the numbers to the right over here, 1, 2, 3, are going to make this inequality true. So with the word and, the question is, what makes both of them true? At the same time, which numbers would make both of these true? And you can see, starting right here at 0, I'm going to start the 0, the numbers in between 0 and 3, and again, open dot here on the 3, make it true. The 0 itself does not make this one true, so it doesn't make both true. And the 3 itself does not make this one true, so it doesn't make both of them true. So my solution is this. If I have to write this inequality with algebraically, this would look like this. I start with a 0, which is smaller than my x's, and these represent my x's right there. And x is also smaller than 3. So I can write an inequality that looks like that. All right, so let's go to our next one. Part B. I have, this time my two numbers are -4 and 2. So I'm going to put my smaller one on the left in all these spots, and my larger one on the right, 2, 2, 2. I'm going to graph x is greater than or equal to -4, colored in dot. To the right, x is less than or equal to 2, a colored in dot. To the right. And again, we're going to look for the numbers, because this is an and, that make both of these inequalities true. So all these numbers, the ones that are in both of them, that -4 itself is in both of them. You see this line is covering it up. So I'm going to put a colored in dot here. The 2 itself is also included in both of them. And the numbers in between are, and so I would again shade these in. So to represent this with an inequality, I'm going to start with my -4. It's smaller than all my x's, and all my x's are also smaller than 2, and that should be less than or equal to. Example C, my two numbers are -2 and +2. So I'll put the -2, a small one, 2 is the large one. X is less than -2, looks like this to the left. X is greater than 2 to the right. And then I'm looking now for the numbers that make both this first one and second one true. And you see there's nothing in common, so there's no points that make them both true. And so this answer then would be no solution for that. So I'd want to write, oops, I wrote it in the wrong place, didn't I? I want to write that right there, no solution. And the last and that we've got, I have 1 and 4. So 1's in my first spots, 4's in my second spots. I'm going to graph x is less than 4, x is less than 1. Now I want to observe which sections make both true. Again, I have the and right there. So I can see that they both have the arrow, they both have here. And when I get to the 1 itself is not in the second one, so it's not in the and part of it. So what makes them both true is this section here. And when I write that, I'm going to have then, okay, describe this with an inequality. My x's, all my x's are less than 1. And that would be my algebraic solution.